In this video, I want to talk about how SysML's powerful composite structure model relates to SchemaSys. In particular, I want to show how certain innovations allow SchemaSys diagrams to retain the full complexity of SysML while appearing much simpler on the surface. For this discussion, we will be using the example of an electrical latching circuit. If, like me, you're not an electrical engineer by training, it may help if I briefly explain how this type of circuit works, independent of SysML and SchemaSys. The circuit consists of a start and stop button, a relay with a single coil, and two contacts and a motor. When the start button is pressed, current is allowed to flow through the coil, causing the contacts 1 and 2 to close. Contact 1 ensures that the coil remains under current even when the start button is released, while contact 2 is responsible for applying voltage to the motor. When the stop button is pressed, the current to the coil is interrupted, causing both contacts to fall back to their default open positions, thereby stopping the motor and resetting the circuit to its default state. Let's take a moment to consider some of the physical characteristics of the circuit. To begin with, we are using a relay which typically consists of a coil, an armature, and one or more contacts. Current flowing through the coil induces a magnetic field which causes the armature to pivot, thereby applying pressure to the contacts. In SysML, we could model the relay as a block with parts for the coil, armature, and contacts. Notice that although the relay is usually thought of as an electrical component, it also uses other physical effects such as magnetic flux and mechanical pressure. This is significant because these other physical forces are ignored when drawing electrical circuit diagrams. In fact, the electrical circuit diagram for the relay completely ignores the armature and its relationships, and what we are left with are the coil and contacts and their electrical properties. Notice that these elements appear here in exactly the same way as they do in the latching circuit. Also notice that in the latching circuit there is no indication that the coil is connected to the two contacts. We'll see how to address this shortly, but for now let's turn our attention to the start and stop buttons. While we could easily imagine the start and stop buttons as separate components, for the sake of this discussion, let's assume that they are part of a push-button control station as shown here. Unlike the coil and contacts in the relay, here the buttons are not physically related. However, they are semantically related, as the stop button is intended to stop whatever it was that the start button had started. In this particular case, there is no ambiguity. However, if the circuit under consideration contained multiple start and stop buttons, then it would be very important to know which buttons were correlated. And in fact, later on I will show an example where we do indeed have more than one control station. Here we can see what the SysML model for the latching circuit might look like. Unlike the SchemaSys diagram, the SysML diagram groups parts according to their membership in higher order structures. So for example, the start and stop buttons are grouped within the push button control station, while the coil and contacts are grouped within the relay. Recall that in the original circuit diagram, there was no visual indication of these higher order structures. As a result, it was possible to arrange the electrical components more freely, focusing more on the flow of current rather than the structural configuration. Let's consider how we might take the SysML internal block diagram one step closer to looking like an electrical circuit diagram. One thing we could do is to allow parts to be displayed more than once per diagram. For example, here you can see that the push button control station S1 is shown once with the stop button and once with the start button. And the same is true for the coil and contacts of the relay R1. By splitting things up like this, we are able to approximate the spatial arrangement of the elements in the schematic. As a side note, this is not to my knowledge valid SysML, as normally parts should be displayed only once per diagram. But there are ways to trick the tools, and I'm simply showing it this way here to explain how SchemaSys works. Another thing we could do is to make the higher order structures invisible. For example, here S1 and R1 are grayed out, indicating invisibility for those parts. Although you might not guess, this is exactly what is occurring in the SchemaSys diagram. To prove this, notice what happens when I select the stop symbol. The label next to the symbol shows S1, and we can see that the property view has switched to S1. This indicates that we have selected the push button control station and not the nested stop button. If I click on the selected component again, then the label switches to S1 stop, and the property view switches to stop. This tells us we have now selected the nested stop button. A third click brings us back to S1 again, and in this way we can cycle through any composite structures that exist but may or may not be displayed. The same principle applies if I select one of the stop button's ports. The label next to the symbol shows S1 stop 1, indicating the stop 1 port of the S1 part. If I click on the port again, the label changes to S1 stop NC1, indicating the NC1 port of the stop button within S1. It may help at this point to illustrate what is going on in the SchemaSys diagram internally. Here we can see that rather than having the composite part inside its defining block in a 2D plane, we allow for the composite part to be inside its defining block in a kind of conceptual 3D space. Many drawing programs have the notion of z-order, which is simply the order in which elements occur on the z-axis. The z-order affects whether an element occludes other elements, which would be a higher z-order, or is occluded by other elements, which would be a lower z-order. In the case of nested parts, SchemaSys enforces a z-order that corresponds to those nestings. Notice that the only features of the push-button control station to be displayed are the stop button itself and the ports that delegate to the stop button. These ports, though technically there, are completely occluded by the stop button ports. The delegating connectors are not shown since they effectively collapse into a single point. Looking at the SysML and SchemaSys views again, we can now understand how the SchemaSys diagram actually contains the same information as the SysML diagram while appearing to be a more flatly structured circuit diagram. This is an important step on the path to linking SysML with schematic diagrams. However, there is one more improvement we can make. To explain what that is, let me show you this alternative view of the latching circuit. Notice that the start and stop buttons are now prefixed with S1, while the coil and contacts are prefixed with R1. This tells us that stop and start are part of the control station S1, while L1, C1, and C2 are part of the relay R1. This technique of prefixing is frequently used in schematic drawings to indicate membership to a higher order structure and is basically a direct alternative to the nested parts of internal block diagrams. A naive way to achieve this would be to simply rename the elements to include the prefix. However, remember that S1 and R1 signify context-specific usages of the more general push-button control station and relay components, and simply renaming the elements would incorrectly affect all of their usages. But, of course, SysML has a mechanism for dealing with such cases, and that is context-specific values, also known as initial values. Going back to the original internal block diagram, here you can see that the electrical components have an ID that can take on context-specific values. For example, the start button has the ID S1.start, indicating that the start button occurs here within the context of the S1 push-button control station. If, for some reason, we needed to introduce a second control station, say S2, then the ID of that control station start button would be S2.start. So far, we have only seen examples of fairly simple composite structures. However, the same principles apply no matter how complex the system becomes. To illustrate, let's imagine for a moment that we wanted to use the latching circuit not only for driving a motor, but for driving any electrical component more generally. To do this, we would need to remove the motor and replace it with a general-purpose interface. Here, this interface is represented by the V-high out and V-low in terminals. We could then reuse this generalized latching circuit in any application we choose. For example, here the latching circuit is used once to drive the motor M1 and once to drive the lamp P1. Notice that the electrical elements with the latching circuit now have the prefixes LC1 and LC2 to distinguish between the two usages. Also notice that the motor and the lamp do not have any prefixes, as they are direct members of the containing block of this circuit. It is also worth pointing out that the electrical connections are easy to follow, even though, in reality, they are passing back and forth between many structural layers. To round off this video, I would like to show how these ideas are integrated into the user experience. Let me do this by contrasting two different scenarios. In the first scenario, we would like to place the start button on a diagram representing the push-button control station. To do this, we simply select the start button in the containment view, then select the symbol we wish to use and drag and drop it to its destination. Unsurprisingly, if I now select the start button in the diagram, I can see that it is actually the start button itself and not the push-button control station. Selecting one of the ports confirms that there are no delegating ports hidden beneath this symbol, which is, of course, what we would expect. In the second scenario, we would like to place the start button on a diagram representing the latching circuit. This time, we will do this from the structure view, which allows us to see parts within parts. So, First, I open up the push button control station S1, and then I select the start button from there. Notice this time that the symbol view shows the start button with the S1 prefix. This tells us that SchemaSys is aware of the context, and when I now drag and drop the start button to the diagram and then select it, we can see that we do indeed have both the control station S1 and the start button. Again, selecting one of the ports confirms that there are indeed actually two ports, the delegating S1 Start 1 port as well as the S1 Start NO1 port. What has actually happened is that SchemaSys has created the outer invisible part view for the control station automatically based on the context. The first part of the context is what is sometimes referred to as the property path, which in the first scenario was simply start, but in the second scenario was S1 start. The second part of the context is whether or not the ports shown in the symbol have any delegating connectors to the outer part. In this case, S1 start NO1 has a delegating connector to S1 start 1. Because of this, SchemaSys assumes that you will probably want to connect to the inner ports via the delegating outer ports, and so creates the outer ports automatically. Had there been no delegating connectors, SchemaSys would simply have created the invisible view for the outer part S1 with no ports, since the only thing you can really connect to in this case are the ports of the start button itself. The point I simply want to make with all of this is that these kind of user interaction enhancements are a crucial part of what makes SchemaSys work. Without them, clever though the rest may be, forcing users to fiddle about with invisible nested parts every time they want to place a symbol could quickly result in an unusable solution. As it is, creating schematic drawings with SchemaSys is actually quite easy and even enjoyable. But now I'm curious to hear what you think. What is your reaction to all of this? Does this address a need that you have? Do you think this approach makes sense, or would you do things differently? Are there any particular aspects you would like to see discussed in a future video? Be sure to leave a comment below, and don't forget to like, share, and subscribe. Have a great day, and I look forward to seeing you in the next video.